in 1 minute.
सृष्टि, तुम्हारे जूनियर्स कोई नहीं है क्या जो ये फेलोशिप ज्वाइन करना चाहते हैं? सारे कोयम्बतूर से ही हैं स्टूडेंट्स, तुम्हारे बाद कोई है ही नहीं। हाय सृष्टि।
हेलो।
Hi,
सृष्टि,
ma'am.
तुम्हारे बाद ये फेलोशिप ज्वाइन करने के लिए कोई नहीं है क्या? ऑलराइट, Dhitiman is back. We will start the class.
Actually, it's raining quite heavily in Bangalore, and like one of the windows was open, so it was like banging
No issues,
and
go
shut,
ahead.
so I had to close it. Yes, ma'am. Okay, so I'll straight away get to it. So today's topic for presentation is going to be hardcore data analysis. I'll be starting with the basics. Mostly, I'll be talking about descriptive statistics today, and if there's time, then I'll go on to a general framework of all statistical analysis. I'll try to be quick because we are a bit short on time today. So I'm sharing my screen now. Okay. Am I visible? Is my screen visible?
Yeah.
Okay, madam. Okay. So first, let's talk about the types of variables that are there in traditional data analysis. So if you go through any of the textbooks which are there of data analysis or refer to any of the articles which are there online, since they try to be comprehensive, like they try to cover everything in one go, what usually happens is that we end up with a large number of types of variables, and we usually get confused, especially if we are the beginners in data analysis. So I will here propose a system which will help you to like categorize each and every variable that you will ever come across into one of three buckets. Okay, so whenever we talk about types of variables, then broadly we have three types. Okay, and to diagnose these three types of variables, we have only and only two specific categorizations. Okay, the first thing that you need to ask yourself, does your data have any increasing or decreasing order in its values? Okay, so like basically if you talk about variables, qualitative variables such as your male female or Hindu Christian Muslim, so these type of variables do not inherently have any order between the levels of the data. Like here the levels being like yes, no, male female or Hindu Christian Muslim, so you do not have any inherent order between the levels of the data. So whenever you do not have any order between the levels of the data, then the type of the data we call it as qualitative, or more specifically nominal. Okay, nominal being derived from the term name. So basically the levels of the data are just that, they are just names. They don't have anything to do with any categorization based on any hierarchy. Okay, so no hierarchy. The next thing that happens is that if next question you need to ask yourself, is whether there is a difference in whether the difference between two levels of the data is equal or not. Like suppose we talk about variables such as heart rate. Okay, your heart rate is like 70, 71, 72, 73. Okay, so the difference between 70 and 71 is the exactly the same difference between 72 and 73, same from 82 to 83, same from 83 to 84. Okay, so because of that your this type of data is known as a interval scale data or a quantitative, typical quantitative data. Okay, if for example your this one does not have any level, does not have equal representation between the levels, like suppose we are talking about ordinal, suppose we are talking about something like VAS. Okay, although we specify it as 1, 2, 3, 4, between 3 and 4, so on and so forth.
Nirtimal, we've lost contact.
Okay, I'm back. Where did you people lose me? I kept on talking, so I have no idea. Am I audible?
Yes, at the minute, yes.
Okay, okay. Where did you people lose me? Like, I actually went beyond the types of data. Where did you people lose me? Okay, I'll just start off with the types of data itself again. Okay, so whenever we talk about types of data, we talk about we have to think about two specific parameters. Okay, whether there is an order to the data or not. Okay, so when we talk about data such as binary data, such as your yes and no, male, female, or we talk about the types of data such as the religions, Hindu, Christian, Muslim. So in this type of data, there is no inherent order to the levels of the data. Okay. So because of that, these types of bits are known as nominal, in which there is no hierarchy between the levels of the data. Okay, nominal literally means name, by name. So because there is no meaning to the levels of the data other than the name of the level itself, so we just call it nominal, and there's nothing more to be discussed about that. Okay. Next, we have to next, if there is an order to the levels of the data, such as heart rate, such as your VAS score. Okay, so there is an inherent order, like VAS 10 is definitely more than VAS 5, or heart rate of 75 is definitely more than 72. So there is a hierarchy here. However, we have to next ask ourselves, there is a difference between the whether the difference between the levels of the data is exactly the same or not. Okay. Now, suppose we talk about heart rate. Okay, the difference between the levels of 70 to 73 or 76, 77 is exactly that of 1 beat per minute. Okay, so it is always going to be the same. So these type of data are known as interval type of data, interval scale data, because the interval between the levels is exactly the same. Okay. Now compare that to other type of data such as VAS. Okay. So in VAS, although it is numbered as 1, 2, 3, 4, and you can say that the difference between 1 and 2 is the same as difference between 2 and 3, but what is the meaning of each of those levels? Like the meaning of VAS 2 and VAS 3, VAS 4 is cannot be quantified very specifically. It is like a interpretation based scale. Okay, so because of that, the difference between a VAS of 1 and 2 may not be the same as difference between VAS of 8 and 9, right? So because of that, because there's no difference of, because the difference between the levels of the data is not exactly the same, so because of that, it is known as ordinal. It has only order associated with it. So whenever you come across any variable in your data analysis or as part of your projects or thesis, just ask yourself two questions: whether it has any hierarchy or not, and whether the difference between the levels is exactly the same or not. Okay. Now, if you want to elaborate further, the interval scale type of data can also be broken down into ones which can go into decimals versus those which do not go into decimals, which stay as integers. Okay. So, like some variables can be expressed as decimals, which are like BMI. Okay. Or the other type, like the ones which cannot be expressed as decimals, like age. Okay, so age is either 1 or 2 or 10 or 50. Okay, so those types of interval scale variables which have no decimal representation are known as discrete data, versus those that have a decimal representation are known as continuous data. So that is like a pedantic classification, but broadly speaking, you will only encounter 3 types of variables, and it is just easier to keep it simplified in your head like that. Okay. Next, we come to description of data. When we have to tell another reviewer or a reader about the data that you have gotten, you cannot literally just give them a list of numbers, right? You have to summarize it in some way that makes some legible sense to the people in front of you. Okay, so this summarization into some specific parameters is known as descriptions, description of the data. Okay, now there is another term for it which sounds very fancy, but it is actually not. That is called models. Okay, like when you say that this is the average or the mean of a data series, you are literally denoting that data series by that number. So that basically means that you are summarizing it, or you are providing insights about that entire data series in some way to the reader using that number. Okay, so this simplification of the entire data series is what we call modeling of data. Okay, so modeling can range from anywhere between description to full-fledged regression analysis and so on and so forth. Everything eventually tries to simplify the data, get some insight from it, and provide a simplified insight to the reader so that they understand what you are talking about. Okay. Now, there are many different types of descriptors of data, and most of you will have heard of many of these, but still I'll go through these and try to tell you what are the differences between each of them. Okay. Now, and we'll go by it by the type of data wise. Okay. When we talk about interval scale data, okay, we talk about broadly two types of broad categorizations of descriptives. First is some measure of central tendency, meaning you try to find out the center point of the data. Okay, so basically an easy way to visualize data is by seeing a center point and how spread out it is around that center point. Okay, that is like one of the most simplest ways of understanding what a data can be visualized by a reader. Okay, so the center point is called a measure of central tendency, and your spread out around the center is known as a measure of dispersion. Okay, let's talk about the measures of central tendency. I think all of you know what a mean is or an average is. It is nothing but the sum of your data series divided by the number of items within that data series. Okay, so the mean is a useful metric. Like many times I tend to disparage the mean because it has a few disadvantages. However, it makes a lot of intuitive sense to a reader when you try to describe a data using mean. So mean is a useful metric. However, an even better metric is the median. Okay, now the mean is supposed to be the theoretical middle point of your data. Now, why am I saying a theoretical middle point? Because it may not be the exact middle point. If you have got large size data on one side of the extreme, like you have either a very large data point in your data series or an extremely small data point in your data series relative to the other data points, then what happens is that the mean gets shifted away from the middle towards those. So this is the effect of presence of outliers in your data on the descriptives, that is mean. Okay. However, median is going to be always exactly in the middle. It does not matter what your outliers are there or not. It will always be exactly in the middle. So because of that, your median is almost always the best way of describing a central tendency of a data. Okay. Now I will show it to you visually here. Now, suppose this is the histogram. Like just imagine that this is the histogram of a data series. Okay, and suppose this is the middle point. Okay, so this type of distribution is called a symmetric histogram, in which you have got a single center, single peak, which is called unimodal. That's a single peak, and it has got symmetrical tails to the ends. Okay. However, if you had a few number of a few data points which were extremely high, meaning that their numbers were low, but the magnitude was high. Or you had a few data points which were extremely low, meaning that there were few data points, much less than the total number of data points that you have, but their value was extremely low. Okay, then what will happen is that the mean will get pulled towards those ends. Okay, so basically, if it is this type of data in which you have got the peak shifted to one side and a long tail to the other side, these type of histograms are known as skewed histograms. Okay, so skew is always defined by the tail. Okay, now this is known as a positive skew or a right skew. Okay, so in which you have got a,
Ditiman, just 1 second.
yes,
I
madam.
think your screen is not visible.
Oh, okay. 1 minute, madam. Uh, okay, ma'am. You have to like I have sent a request for sharing. Host isn't allowing sharing for this meeting, madam. Request. Okay. Now is my screen visible?
Yeah, it is. Thank you.
Okay. Okay. So, I was talking about so if you have data which has got a single peak, okay, that type of data is called unimodal. And if it has got symmetrical tails, then it is called a symmetrical histogram. Okay. Now, sometimes you will have data which will have a small number of high magnitude values compared to the other values in your data series, or you will have some data series in which you have got a very small value but small in less number. Okay, so these type of data series are known as skewed data series. Okay, now the important thing to remember in this is that the skew is always defined by the tail, not by the peak. Okay, so many times we get confused that okay, the peak has shifted to this side, so it will be a negatively skew or a left skew, so on and so forth. No, it is always defined by the tail. So if you have got a positive skew, that means the tail is going to be long on the right side or the positive side. And similarly, negative skew or a left skew will look like this. Now, what happens to the mean is that it always gets pulled towards the tail, meaning that very large or very low values will always tend to pull the mean towards it. Okay, it is very easy to understand it conceptually when you know the formula of the mean. Like basically, one small value gets distributed among all the other values, and because of that, your mean shrinks. And if there's a very large value, that gets distributed across all the values and your mean suddenly jumps. Okay, so that is why, and because we do not usually have symmetrical data series usually, because of that, what happens is that it's almost always a better idea to go with the median as a measure of central tendency. Okay, so median will always stay in the middle. Okay, now, uh, there is no specific formula for calculating the median. It is basically exactly the middle point of your data series. You basically order your data series from minimum to maximum, and whatever is the exact middle point, that is your data series. If your that's a median. If your data series has an even number of values in which you cannot have one single middle point, then the average of the two middle values is taken as the median. Okay. So this is about the difference between median and mean. Now forget about mode. Mode is universally never ever used as a measure of central tendency. It is more useful for describing, sometimes, very rarely useful for describing nominal variables. Even there it is not commonly used. For quantitative variables or interval or ordinal scale variable, your mode is almost never used as a measure of central tendency. Okay. Next thing to remember, for ordinal data, always go for median, because for ordinal data, usually your decimal points, which usually are a part and parcel of calculating a mean, will never make sense. Like there is no point of describing the mean VAS as 3.333. Okay, that doesn't have any meaning. It is far better to just say that the median was 2 or something like that. Okay. So for ordinal data, never go for mean. For interval scale data also, always prefer to go for mean unless the reviewer specifically asks or your boss specifically asks to describe the mean, because most people are used to the mean as a measure of central tendency. Next, let's talk about measures of dispersion. Dispersion basically means how spread out the data is around the middle point. Okay. Now I want you to imagine a data series of a series of numbers. Okay, you in the middle. Okay, one of the easiest ways of finding out the dispersion, how spread out the data series is to subtract each of the data series values from the mean, each of the data series. So basically, one end of the differences from the mean will be your positive, one end of the differences from the mean is going to be negative. Okay. Now, if we try to find a holistic measure of dispersion from these differences, these are basically how each data point is spread out away from the mean. Okay. Now, if we try to find out a holistic measure, that will become basically average of these differences. Now, this type of measure is called deviance, or how much deviant each data point is on an average from the middle point. But you would have never heard of deviance as one of the measures of dispersion because of a very crucial flaw. That is that if you add up your positives with the negatives, you end up with zero. Okay. So what happens is that if the data is truly symmetrical, you will end up with a dispersion of zero if you try to calculate it using this metric. However, if you uh, if you have calculated these individual deviances and suppose you square them, then what happens? The positive becomes squared positive, the negative becomes also squared positive. Okay, so now you can very easily average out these squared deviances. Okay, and this average of squared deviances away from the mean is what is called variance. Okay. Now remember that variance is always in the context of when you are calculating from the mean. It has nothing to do with the median. Okay. If you are calculating it in the way of mean as central tendency, then variance has a meaning because it is also an average. Because of that, your variance is always going to be symmetrical around the mean, even if your data series is not symmetrical. But the variance that you will calculate will be symmetrical about the mean because it is also an average. Okay. So because of that, your variance, although it is used very commonly, it's one of the most common parameters which is used for in data analysis. However, variance is a bit too unwieldy to use as a metric of dispersion because of the large size of each number. Like many times for like something like heart rate, your variance, because it is a average of squared deviances, what happens is that the value will come somewhere around in thousands. Okay, so that makes it a little bit less interpretable for us because we are used to seeing the data in its own scale. That is, heart rate will usually be between 50 to 150 or something like that. Okay, so for us it is difficult to comprehend variances when we try to think of data in those terms. However, if you take variance and you square root it, essentially you are square rooting the average of squared deviances. That gives you a metric which is in the scale of your data, and that is called standard deviation. Okay. Now, standard deviation is a useful metric to find out how your data is dispersed about the mean. Okay. And that will be one of the most common dispersion measures that you'll ever read in all of literature. Okay. So I hope your deviance, variance, and standard deviation are a little bit clear, as well as the utility of it. However, as I said with variance, SD or standard deviation is also going to be symmetrical about the mean. It's going to be calculated as symmetrical about the mean, despite your data series not actually being symmetrical. Okay, so whenever you will have skewed data, in those times your mean will either overrepresent or underrepresent the middle point, and your SD will tend to be large. Like the dispersion metric will come out to be large. Okay. Because of that, for skewed data, this measure of dispersion is not very useful. For measuring dispersion of skewed data or of any other data in general, you have to understand the concept of percentiles. Okay. Now let's go to percentiles. Okay. Now imagine you have a data series which has got 100, sorry, not 100, suppose 1,000 data points, suppose. Okay. Now, in those 1,000 data points, you divide it into buckets of 10. Okay. So basically, you basically order them from minimum to maximum, and you make them into buckets of 10. Okay. So basically, suppose you are on the third bucket. Okay. So because you have divided into buckets of 10 and your data series absolute number was 1,000, your sample size was 1,000. Now what you are having is you are having 100 buckets of 10. Now of those buckets, suppose you hold the third bucket. Okay. So you can, if whatever the number represents the third bucket, you can easily say that 3% of the values in your data series were less than that number, right? Suppose we talk about the 99th bucket. You can easily say that 99% of the values in the data series are below this number. Okay, so that is how your percentiles are useful. What you want to do when you are calculating percentile, although you won't need to manually calculate, everything is done by the software now anyway. However, conceptually what happens is that you imagine your data series to be stretched out and you divide it into 100 buckets. And each of those buckets will have a value associated with it of your data series, and whichever bucket you hold, basically that much percentage of your data series is below the magnitude of that bucket. I hope that makes sense. Okay. Now, in itself, your percentiles are not very useful. Okay. However, there are certain percentiles which are useful for us. Like suppose you did not divide your data into 100 buckets. Suppose you divide it into 10 buckets. Then those 10 buckets are known as deciles. Okay. Suppose you divide it into 4 buckets. Then those buckets are known as quartiles. And overall, this system of percentile, decile, quartile, whatever you have it, the overall system is called quantiles. Okay, so quantilization of the data is one of the best methods of showing to the reader how dispersed your data is, because unlike your SD or variance, this is allowed to be uneven or non-symmetrical about the true middle point, that is your median. Get the idea? Now, your the fun part is that because the true middle point is the median, so median is also your 50th percentile or the second quartile. Okay, so basically, whenever you're looking at the median of any data series, you can automatically say that whatever is the number your median is, 50% of your data has a value lower than this number. That's all. Okay. And when we try to usually describe an ordinal data or any interval scale data in this quantile format, then it is basically described as median and quartile 1, that is your 25th percentile, and quartile 3, that is your 75th percentile. So this is the common way of representing. However, if you want to go elaborate, you can go elaborate, although it doesn't make sense. Like you can easily specify your all deciles also. In all deciles, your 5th decile will also be the median, so on and so forth. You get the idea. Okay. So yeah, so that is your so this basically describes your overall all methods of dispersion. There are few other methods of dispersion also which are commonly talked about but never truly used in practice, like your range. Range is basically the difference between your minimum to maximum, that's all. Okay. One important caveat I will tell you people. So sometimes in some papers, you will read the metric standard error of mean used as a descriptive. Whenever you read standard error of mean being used as a descriptive, you can automatically make the assumption that whoever has written the paper does not understand statistics. Okay, standard error of mean has nothing to do with the dispersion, although it has some parts to do with the dispersion, but mostly it has everything to do with the precision of your estimate, precision of your mean. How good has your calculation of the mean been? Okay, that is what your standard error of mean, what it means. Okay, we won't go into details of SEM because we'll be talking about standard errors and general errors and everything, p-values, everything in a separate class. Just know for now that standard error of mean or SEM is not a metric of dispersion. Whoever says otherwise is foolish. Okay. Lastly, coming to your nominal data, the most common way of representing your nominal data is percentages and proportions. So basically, you tell the number of people, that is frequency, and your proportions. Like suppose, let me give you an example. Suppose you had two groups, group one, group two, and within that you wanted to see how many were males and how many were females. So basically, in group one, you will have certain number of males, certain number of females. In group two, you will have certain number of males, certain number of females. So this is your truly a nominal data, right? Now, within this, if you represent the number of males and females in group one as numbers, absolute numbers, that the number of people, then it is called frequency. If you calculate the percentage of it, then it is if you calculate it as a percentage, if you multiply it by 100, then it is a percentage. If you do not multiply by 100, it becomes a proportion. There's no other difference. Okay. However, the important thing to understand here is because that proportions can be or percentages dissect the data. You understand? Like suppose you calculated group one, group two, male, female, male, female. Okay, you had four numbers. Okay. Now, if you use the sum of all of the four numbers, that is your total sample size as the dividing denominator for calculating the percentages, then you will get total percentages or total proportions. However, if you use the number of people in group 1 and number of people in group 2 separately as the denominator for the values in group 1 and group 2 for male female, then you get row wise percentages or group wise percentages. Similarly, you can have column wise percentages also. So it is important to differentiate within the context of your data. This way you want to cut it that way. Total nobody uses mostly. Mostly you are using it in the context of either it is column wise or it is row wise percentages. Okay, so that you will need to specify whenever you are writing the descriptive portion of your data. Okay. So this actually covers most of the descriptive, actually all of the descriptives. Now most of the descriptives luckily can very easily be done on Excel also. However, I would suggest that like although it is very easy to do on Excel, I would prefer that you people learn to use some point and click software for doing these type of descriptive analysis. It makes your life much more easier in the long run. However, in the Excel also, it's not too difficult. So I think, madam, today because of the difficulties we had, I would not start the next section. I would like to stop at the descriptive portion of the type of variables and descriptives. I am happy to field any questions that people have regarding their study or whatever questions they have regarding the class that we had just now.
Tirthaman, what had you planned for today? There was another topic to be done today.
Madam, but that topic will be pretty large. Like I think that will take another at least 45 minutes and there's no point to be covered for that to be covered today.
You know, why I ask is we are taking a summer break as far as our regular classes go. If
Okay,
you're
ma'am.
happy to repeat one of these 10 sessions for the other topic, you're welcome to do it next Friday.
Yes, ma'am. I'm very happy to do it next Friday. No problem.
Okay, then we shall meet again next Friday. Anyone has any question, please ask.
Any questions? Like I'm telling you, like these type of things, although they seem to be very simple, sometimes you can get confused. No question is too dumb, literally.
It was very well put up, Dhritiman. These terms that we think we know, how much ignorant we are, we came to know today. Thank you very much.
Sure.
So we eagerly look forward to the next session.
Sure,
We
ma'am.
shall meet
Next session will
on
be a
Friday then.
little more heavy basically because I'll go into more core data analysis, core statistics basically. So that would be a very useful topic for everybody. Like what I'll be covering in the next lecture would be your general framework of all statistical analysis. So I'll provide you with a conceptual framework which covers all statistical analysis without going into depth of individual tests, statistical tests. And I feel that will be very useful for almost everybody. So yeah.
Thank you so much for taking your precious time out for us.